is recording now. Okay, so what we'll be teaching today is a computer science lesson called Snap Out of It. And then I'm gonna have the next person is gonna introduce this. Andrew?
Yeah, so we're here to teach you guys a STEM lesson today. So do you guys know what STEM stands for? I'm sure you guys heard the acronym before, but does anyone want to unmute and say what the acronym stands for, if they know?
And you can also type it in the chat too.
Yeah.
It stands for science, technology, engineering, and math.
Yeah, that's correct. So yeah, I see people are saying in the chat as well. That's great. So there are a variety of reasons as to why we pursue STEM, not just as college students, but also in teaching it to other people in our community. We can see that STEM is so well integrated into various aspects of our lives, and it doesn't just have to be in an academic setting where we kind of use it and pursue it. So we can use STEM to solve problems in the world. Anything from NASA doing research to further space exploration, or people at Apple or Google trying to improve technology to make our world a more efficient and a better place. They always continuously solve problems and come up with updates to make our lives just better. And with STEM, we can also design super cool things that matter. Just like I said before with Apple, we have these iPhones, these small blocks that we can carry in our pocket that can do everything from GPS to email to anything that has just been consolidated into one small thing. And I think that's super cool. STEM also gives us the chance to work with awesome people. The 6 other Beam friends in this Zoom call with me, I've been able to meet them through this organization that so highly prioritizes STEM and giving such experiences to other kids in our community. And I'm really blessed to have met them and are working with them today. And STEM allows us to make a difference in the world. Like us college students, even though we are still learning and are still growing every day, STEM allows us to gives us an opportunity to meet other kids in our community and try and spread STEM and show people how important STEM is, and introduce kids to the amazing opportunities that STEM has. And we really hope that today's lesson, you get to learn so much more about CS, but also just STEM in general. And just don't be afraid to ask us any questions that you have regarding STEM, or pursuing it down the line in your lives. And yeah.
Alrighty, so STEM kind of means a lot of things. And under that huge umbrella of all the science and technology that you could be doing, we're going to talk about computer science today. That's what our activity today is all about. So first off, I'd like to get like a show of hands. You can type in chat. You can, I guess, say yes in the participants window. Just like, who here has heard of computer science? Who has, no matter what experience you have with it, if you've heard the word computer science before, please let that be known. We got a thumbs up. We got a couple thumbs up because a couple people saying me. Awesome. Bonker knows what computer science is. Awesome. Okay, cool. Now, if anybody is comfortable with it, can I get somebody to volunteer and tell me what they think computer science means? If you've never heard what computer science is, you can tell me what you think it means. If you have experience with it, you can tell me what your experience with it is and what it means to you. I see V tells us it's about coding and programming. And that's pretty much exactly right. The science of programming and analyzing how computers run and algorithms. Awesome. Coding. Okay, those are really great answers, guys. Yeah, can I get the next slide, please? Yeah, so computer science is all about coding and designing programs. And essentially, it's all about how we talk to our computers. Implementation, user testing, and documentation. Wow, you guys sound really smart. Yeah, CS is all about how we talk to our computers. Like, our computers do so many cool things. Like right now, they're showing us our screens. They're letting us communicate to everyone else in this room. Like, you guys are, like, all of us are miles apart, right? And we're still able to communicate to each other. And a lot of that is through the power of computer science, right? We're able to write these programs that let our computers change the ways we communicate, the way our workflow works. and stuff like that. And we do all of that through writing programs and writing code. And I think that's really great now. Like you can learn computer science and you can learn how to communicate with your computer. But I'd like to also argue that computer science is even important if, let's say, you're not really going to be a programmer, or maybe you're never going to touch a computer again for the rest of your life. Why is it important that you should still learn computer science? And that's because on top of learning how to communicate with computers, computer science also teaches us how to solve problems, right? Because like talking to a computer, it's like learning a new language, and you have to, in order to write your programs correctly, you have to think the way the computer thinks. And that's a little bit different than how we think as humans, right? Because computers, they take in different instructions, they're a little more literal. So you really have to, you kind of change your mindset when you learn computer science. And as a result, you learn how to solve these really cool problems in ways you might have never thought of before. Like, and that could involve like say you want your computer to, like you want your program to pick up, like go search for a library book. And I know you guys know how to search for a library book, but there's a bit of problem solving and a bit of finesse that goes into correctly telling your computer how you want it to pick up that library book. And you can even go beyond that and be like, what's the fastest way that I can pick up a library book? That itself is another problem. And let me tell you, there are slow ways and there are fast ways to go search for a library book, right? All of that is computer science, it's problem solving. And problem solving is a really essential skill, which is why computer science, no matter what you do, even if you're never gonna touch a computer again, after today, if you, like, I urge you, please, at some point, like try to delve into computer science. Is gonna be useful to you because problem solving is gonna you can apply it to anything in your life. Can I get the next slide, please? And now this is something we hear a lot. Coding looks hard and I can't do it. And I feel like I don't have the background. I hear that so many times. And like, you can say that about literally anything, but I'll tell you, like, it's totally possible that like coding is not as far of a stretch as it kind of seems. Like I said, it's really just like learning a new language because you're learning to talk computer language. Yeah, if that makes sense. Like, is anybody here bilingual? Does anyone here speak anything other than English? Cool. Can you guys tell us what your other language is? Russian? I speak Vietnamese, awesome. So Spanish, French, Latin, Python, Chinese. Yeah, so it's totally Tamil too. Okay, awesome. Like it's totally possible. Like you guys know more than one language already. So it shouldn't, it wouldn't be like super easy. Like coding is definitely a challenge, but it's not impossible. Coding is just another language, right? You can learn it. Can I get the next slide? And so basically you can code. It's literally just, it's a new skill. Like you start from the bottom, you build up and you build up from there. And yeah, that's what we want to show you guys today. That coding really is not something to be afraid of. And we hope you guys have a lot of fun with today's activity.
All right, so we're gonna get started on the actual modules. So module 1 is computer talk. So what is a computer and what is a programmer? Does anyone want to speak up? Oh. Does anyone want to speak up and maybe give a short definition of what a computer and what a programmer is? I'll give you like 20-ish seconds, maybe. Okay, so a programmer and a computer. The computer is the thing that the programmer codes and the programming is the coder. Yeah, a computer is an electrical device. Yeah, so a programmer, if I can get the next slide. A programmer and a computer. A computer is a machine that you type into and it interprets what you're saying to put out like a display or a number or anything, right? A programmer uses a language, which is your instructions, into the computer, and that's how you get your outputs, right? So it'd be like, if you guys have ever seen like a function where you put in like an equation, you put in a number and you get a second number out, it'd be like y equals 2x plus 4, right? Your input would be your x, so you put in 1, you type in 1, and then 2 times 1 plus 4 is 6, your output is 6, right? So programming is essentially a lot of different functions, like orders of thousands and thousands of functions that output something like your computer display, right? Your computer display is just a function of a bunch of different numbers and equations that make me move, can interpret the sounds that I'm making into your ears. And yeah, I think that's pretty incredible. Now, there are lots of different ways we can talk to computers. I saw some people already doing it, but could you guys name some programming languages that you know in the chat or just speak up?
Siri.
Siri could be considered. Siri uses what we call Siri. That's called a user interface. Right? So Siri is something that you input your instructions into, but Siri is programmed already, right? So programming has been done so that your words turn into something that the computer can understand. So in a way, it's kind of like programming. Scratch, Lua Code, MATLAB, there's lots. Assembly, yeah. So speaking of assembly, there's different levels of programming. We have high-level programming and low-level programming. Now, that doesn't mean that they're different from each other or like one's better than the other. Some people might say that, but high-level programming basically means that you're using like a compiler, which is a little, you can imagine as like a little window where you can type stuff into, and it'll interpret it into machine code, right? So machine code is, I know that's getting a little technical, but if you guys just sort of stick with me, machine code is what the computer understands, and source code is what we use to speak with the compiler, right? So high-level programming, source code. Compiler, then low-level programming, machine code. Machine code is just zeros and ones, but source code and high-level programming is where we type out like words like, oh, display this, or print this, or this function is this. And then the computer will be like, oh, 0100100101. So that's essentially how it works out. Oh, interpretive languages too. Yeah. I think that might be a little bit beyond the scope of, I don't think it's actually in my notes, but yeah. So that's essentially how the basics of computer programming and the sort of ways in which we can communicate with computers.
All right, hey everyone. So as was kind of mentioned before, as Andrew mentioned, Alison mentioned, as well as Alex mentioned, computers think very literally. So what that means is that we have to give our computers very specific instructions. So some of you mentioned Python before, really popular coding language. So when programmers use this type of language, they actually have to tell the computer exactly what to do, otherwise it won't work. So as a group, our activity is we're going to be drawing a house, a car, or a flower. And during this activity, we can't just tell kind of, our program, draw a house. We have to tell it exactly how to draw that. So we have to tell them, first draw a line that goes up, then a line that goes horizontally, giving those very, very specific instructions. So what we're going to do is we're going to split up into breakout rooms, and us as beam mentors, we're going to act like computers, and you guys are going to be the programmers giving us instructions, and then we're going to be drawing it on the whiteboard as you guys tell us. So it's going to be exactly what you guys say. And the goal is to make it, as much as we can look like a house, a car, or a flower. So it's going to be a team effort. So yeah, we're going to go ahead and spit out to make it proofs now.
And then what else should I do?
Then you draw on the bottom of the rectangle and push your mouse and draw 4 like rectangle thingy.
4 rectangles like this.
Yeah.
Yeah.
Awesome.
And in the middle of those 2 eyes, go down and make a circle.
A circle.
Push. Yeah.
Okay.
And then next to the circle, draw like 3 line thingies. Push your mouse and draw 3 line thingies.
3 lines on each side.
Yes.
That looks beautiful. All right. Is everyone happy with their picture?
No, I have a cat right here and it's missing a tail.
It's missing a tail? Okay, how should I draw the tail?
Draw a rectangle sticking out of the back of the rectangle.
Okay, there you go.
I have 2 cats at home.
Oh, that's awesome. Oh, what are their names?
His name is Sylvester.
Really? That's
Yeah.
awesome. Okay, so I'm going to stop sharing and we're going to head out to the main breakout room, okay?
Okay. Should we just leave the? Never mind.
Yeah. All right, I'm gonna wait for a few more seconds until everyone's back. Okay, I think everyone should be back. All right.
All right. So what did everybody think of that module? Was it easy? Was it hard? What did you learn? Feel free to unmute yourself or type in the chat. Either works, whatever you're more comfortable with. Drew a house and a tree. The house was 2 stories. Okay, that's awesome. Used a loop. Okay, a cat. Was there anything difficult about drawing the house or the flower or the cat?
The house was kind of difficult because it was hard to like say the commands,
Mhm.
and yeah, it's kind of.
Okay, awesome. So what did you guys like try to do at first, and maybe how did you change it after you saw like what the computer drew? To be very specific and tell exactly what to do, or you get random lines. Yeah, exactly. So that's really cool, right? And over time, you realize that, okay, I have to be very specific. I have to tell the computer exactly what to do because the computers push mouse. Yep, exactly. It'd be very literal in terms of instructions because even though computers can do a lot of things, without us to tell them what to do, they're not too good at doing anything at all. All right, can you go next slide? So what you guys just ended up doing was making an algorithm. An algorithm sounds like a kind of complicated word, but really it's just a bunch of steps to complete some sort of a task. And as Austin mentioned earlier, algorithms are very important, not only in computer science, but in everyday life. So even if you aren't necessarily able to code something up, but you understand how the steps and the logic behind it work, you're basically 90% of the way there. So an algorithm can be something really simple. Say you're putting on your socks, right? You'd say, put on your right sock, put on your left sock, then put on your right shoe, and then put on your left shoe. Or in some sort of order that maybe you guys do it differently, maybe left side first. But it can also be something super complicated, like the algorithms that are being used for us to see each other right now and transmit our Wi-Fi signals and videos.
And encrypt the communication.
Oops, say that one more time.
And encrypt the communication.
Yeah, exactly. So that we can all, so then there's no like lag or anybody like hacking into our call or anything. Exactly. Math algorithms are a different type of algorithms. Yep, that's also true. Actually, so math algorithms are very special. Math algorithms are also step-by-step instructions, usually to find like a value of an equation. And when you're doing computer science, we're also sometimes doing those math algorithms. So in computers, you can solve for what a graph looks like. So kind of how you guys just use lines to draw the house, the computers can draw lines for a graph. The Pythagorean theorem. Yep, everything has algorithms. That's exactly right. Everything in your life is using some sort of step-by-step instructions. But if you guys, can you go next slide, Summer? Yep, so if you guys noticed when you were drawing your things in the previous module, sometimes it can be kind of tiring to say the same thing over and over. Like say you were drawing the petal or of a flower. I think somebody mentioned that the petals were very difficult to draw. So imagine making the computer do that same thing for each petal in the flower. That'd be kind of annoying and it wouldn't be super efficient. So what we can do is we can use a special type of implementation called a loop that makes our programs easier. And a loop kind of says to continue doing something while we want it to be done. Next slide again. So there's a couple of different types of loops that we can use. So we can use a for loop, a while loop, or an if statement. And the way I like to think about it is not in terms of code, but say you are having dinner with a couple of friends. So say we need to order our food, right? So we say for each person there, we're gonna like buy one appetizer, if statement is wrong. All right, we can get that in a second. But so we can say we can buy one appetizer, we can buy one entree, and then buy one dessert for each of the, say, 4 people we're eating dinner with. And instead of saying, just typing buy appetizer, buy entree multiple times, we can say for each person, just buy something, which makes it a lot easier for us. And then a while loop is say we don't exactly know how many, like the n number of things we need. So it could be something like while we're eating, say while I'm still hungry, continue to eat. There's no like necessarily like set number that we might specifically know, like after eating 20 bites end, we're just gonna say while I'm still hungry, I'm gonna keep on eating. So that's gonna continue to repeat the code until that condition is met. Lastly, we have an if statement, which I think somebody caught in the chat, might not necessarily be a loop, but what we wanna do is we're gonna do a code only if a certain condition is met. So let's say if one of the meals I order is soup, if the meal is soup, I'm gonna eat it with a spoon. Or if I have a fork, I'm not going to use a spoon. No. If I have a salad, I'm not going to use a spoon. So we can go into some examples of how these loops look in our code. So this is going to be would anybody like to say in the chat or say aloud what they think this code is, a for loop or a while loop?
It kind of looks like that. So it says when run, you work 8 hours, and that gets you 15 pay. And every time you repeat 1 hour, or yeah, repeat hours worked times. So how many times? It doesn't show how many times, but times. And then so maybe hours worked is 1 hour. I'm gonna think that, and then each hour gets you $15.
Awesome. Yeah. So that's exactly right. So this is a for loop. So instead of saying for like every single hour, we're gonna just get paid our wage, we're just gonna say for each hour that I work in a day, which is gonna be an 8-hour day. We're just gonna work and then we're gonna get paid for each hour. So that makes it much simpler to condense the code and make it easier to read. Can you do the next slide? All right, here's another example. It might be a little bit blurry, so I'm gonna read it out loud. It says repeat until the money in our wallet is $0. We're gonna buy a $1 ice cream cone. So does anybody want to volunteer and say if this is a for loop or a while loop? A while loop? While. Okay, sounds like a good consensus that we've all agreed on. Would anybody like to explain why this is perhaps a while loop?
Because it says repeat until.
Yeah, exactly. So we're saying while we still have money in our wallet, basically. We might not necessarily know the starting amount of money, but we're going to say we're going to buy as much as we can using the amount of money that we currently have. And until we run out of money, we're going to keep on buying something. All right, and then lastly, we're going to look at if statements. So this is saying if you are hungry, we're going to eat a Snickers, kind of similar to that commercial. I don't know if you guys have seen it, because I don't remember the catchphrase, but it's a pretty funny commercial. Or you can say if there's something going on, we need to do something. So if it's raining, then we're going to bring an umbrella. Otherwise, there's no point in carrying the umbrella. Would anybody like to suggest some other kind of if statements you use in your normal life?
You could be like, if get out of bed, and well, wait. If wet, true, then dry off with towel.
Yeah, that sounds good. If I eat pasta, I use a fork. Yeah, those are great examples. So you are using these kind of algorithms. If asleep, wake up. Yep. After you get your 8 hours of sleep, you gotta be very healthy. But yeah, exactly true. So you're kind of using these algorithms in your daily life, and we can always condense them to make it easier for the computers to understand. So I'm going to pass it off back to Andrew to talk about our next activity.
All right. So, oh, sorry, I was saying.
Oops, we got to turn up.
Oh, no worries. All right, so let's get started with the second module. So we're going to be doing Simon Says, but instead we're going to call it Computer Says because you're going to follow what the computer says. So I'm going to show you guys in the following slides a bunch of commands that have like if statements, for loops, while loops. So applying what you just learned in the last few slides that Ishan told you guys about, let's try and execute these commands correctly. So a bunch of these kind of require you to have your camera on because they're kind of funny and make you do like certain actions, but it's okay if you guys can't have your camera on, but we highly encourage you guys to, so we can see and give you like feedback if we need to. All right, so let's go into the next slide. So this is the first command that the computer says. So I'm gonna give you guys like 30 seconds. Let's see if you guys can kind of execute what this command says. It says, if name starts with a vowel equals true, then mark yes on Zoom, else mark no on Zoom. So let's see what you guys say. Yeah, so it seems like you guys are getting the hang of it. So I see that like Andy and Austin, their names start with vowels, so they're putting yes. But Lynn, Mariam, Pranav, their names start with consonants, which is kind of the only other option. If your name doesn't start with a vowel, they're marking no on Zoom. So it seems like you guys got the hang of it. All right, let's move on to the next example. Okay, here's another one. If your favorite color is blue, if favorite color is blue is false, then comment not blue, else comment blue. So Miriam asked, where do we define the pink block? So I use Scratch to make these blocks. So on Scratch, you can custom make blocks to have like really silly commands as you see on here. Scratch did not have these blocks by default. Just a
It also
disclaimer.
gives you run without screen refresh.
Yeah. All right, so it seems like you guys got the hang of it. I'm liking the participation. So everyone whose favorite color, oh, yeah, no worries. So if everyone whose favorite color isn't blue, they're commenting not blue, and otherwise, the only other option is to have your favorite color be blue, and whoever fulfills that condition is commenting blue in the chat. So that's great. All right, let's move on to the next slide. So we have this one over here. Repeat until the mentor holds their hands up is true. Pat head and rub stomach. So I'll be the mentor that holds my hand up. So everyone, all right. Wow, what if I just never raise my hand up? Great. I can see a lot of people patting their head and rubbing their stomach. All right. Great. All right. So once I raise my hand, everyone should have stopped. Everyone should have stopped patting their head and rubbing their stomach. See, I told you guys these would be like silly functions, and Scratch does not have these functions by default. I typed them. All right, so the next slide. Oh. All right, so wow, everyone's spamming the chat. Yeah, so it seems like you guys got the hang of it before I even need to talk about what it said. So the computer says repeat 5 times, comment beam in the Zoom chat. So if we can go to the next slide. So was this a while loop or a for loop? So I think back
This is
to
a
what.
for loop.
Right, that's correct. Blake, can you explain why this is a for loop and not a
It's
while
a
loop?
for loop because a while means repeat until, but that only says repeat a number. And the other reason why is in Python, the repeat is for X in range, however many times you want to repeat it.
That's correct. Good job, Blake. So Miriam asks, are repeat and for loops the same? So the concept of a for loop is that you do something for a certain amount of times. So my bad, Scratch doesn't exactly have this. The Scratch version of a for loop, they use kind of like a repeat block for a certain amount of times. So perhaps in different languages, there are different ways that different things are specified, and perhaps some obscure language, the for loop isn't called a for loop, and they might call it a different way, just like how Scratch calls it a repeat block. All right, so let's move on to the next example. Okay, so here's kind of a challenging one. All right, so I'm going to be the mentor. So try and follow what the command on the screen says. And I'll be the mentor. All right, so I see Krish already waving his arms, but he didn't notice that this is the command says until mentor is clapping is false. So I haven't even started clapping yet. So I don't know why Krish is waving his arms already. I'm just kidding. All right, so I'm gonna start this right now.
I'm doing whatever I'm supposed to be doing.
Oh, okay. All right. Yeah, see, I see you guys are following the commands. All right. Yeah, see, good job. So everyone stopped when I stopped clapping because that's what the command says. Mentors clap, repeat whatever is below in the if statement until mentors clapping is false. Yeah, so when you get more into coding, you might see kind of more complex blocks that incorporate both loops and if statements. And as you get like further down, you're gonna like learn so many more topics that kind of just meld into each other and all kind of bounce off each other to execute a certain function. So let's go on to the next slide. So was this a while loop or a for loop?
It's a while on the repeat until, and then
Yeah.
an if isn't really a loop, it's more of a logic thing.
That's correct. Yes, I see some of you guys in the chat also saying it's a while loop. So can someone explain why this is a while loop?
Because if it's repeat until mentor's clapping equals false, that's the same as while mentor is clapping, do this.
Yeah, that's correct. So you guys had to keep doing the function until I stopped clapping. So that's kind of do this while I'm doing this until this certain condition is met. All right, and that was the last example.
Okay. So yeah, for our last activity, we're going to be actually starting to practice coding on our own. So yeah, we're going to be working with a website that will help you add features to the game Flappy Bird. I don't know if everyone remembers that game or not, but yeah, basically it's a little bird that like goes up and down. And so we'll kind of take a basic implementation of Flappy Bird that has already been built, and we'll be adding some extra features to it. So that should be really fun. Next slide. Yeah, so if everyone can go to this website and sending the link, so the link is in the chat. So we'll be having you guys, okay, yeah, so a couple people have already done this. I think once you're in breakout rooms, we have a couple of other websites for you guys to check out if you've already done this. That's great to hear that you guys are already doing this stuff. That's super cool. But yeah, so we'll work on this kind of together in breakout rooms. Basically, you guys will kind of be working individually. And then if you have questions, you can ask us, or if you want to know more about something, you can ask us. Yeah, so we'll be working on this in breakout rooms. And yeah, let us know if you've already done it before. We can give you kind of other resources to look at for kind of other activities that are a little bit similar if you've already done this. So Summer, if you want to open up the room.
Summer, room 2 only has one participant in it. Are you balancing them out a little?
Yeah, I can move them into breakout room 1.
Looks like everybody's.
Okay, so it's studio.code.org/flappy/1. I'm gonna. I don't know how to share my screen for this. Hold on. Oh. Share screen. Where is share screen? Please. It's much more difficult than it needs to be. Okie doke. All right. Fantastic. Okay, so here's what it looks like for 1. This actually shouldn't be there. I can't keep up with chat either. Okay, hold on. Okay, so if you guys have any questions, I'm going to keep moving through this. Let's see if Blake is left.
Also, feel free to do it on your own like computer too.
Yeah, so I'm going to have this up here, and if you guys have any questions, I'll move to the spot so we can talk about it.
So where do you create it?
Say that again, I couldn't hear that, sorry.
I've used it before, but where's is there like a thing for making Flappy Bird? Is it project ideas? Or?
No, so this website essentially it sets it up so that you have the game, right? So the game is going to be right here, and you press run, and it runs whatever code
it starts out with it.
Sorry, my internet is not that good. It's really hard to hear you guys. You can try typing it in chat. You type your question in chat. Yeah. Hold on. Let me try something. I might turn off a couple devices. See if that helps. All right. So Blake, I know you just got back from.
I've got it now.
Okay, cool. Awesome, Casper. So Blake, I know you just got back. If you guys have any questions, either just speak up or type it in the chat, and then I can go to that spot so I can jump around if you need me to. And we can just, oh, here we go. We can just, I can help you guys out. Oh, organizing this is so difficult. Okay, cool. All right, that's great. So does everything work out, Daniel? Have you finished all the way through 10? Awesome. Did you find anything difficult about this, or was it pretty easy? Yeah. So the great thing about sites like code.org or other like block programming like Scratch is that it's very easy to visualize everything that's going on. So you can see like, oh, because in actual code, it's not always as clear. So seeing it organized in such a way where you can see the flow is much easier. I think I could probably pull up some of the MATLAB code that I have. I'm not sure.
Are you guys writing on the other links that I sent too? I'm not sure if you guys saw that, but there's like a Minecraft one and like another one.
Ooh, a Minecraft one.
Oh yeah, you have that little Enderman face as your profile picture. Yeah.
I think I've done some of these.
Code.org/Minecraft, yeah.
Yeah,
So-
I've done code.org before.
Oh, okay, there's another one called snap.berkeley.edu. That's just like another version of Scratch, but kind of like more complex version of it. Yeah, so like what Alex is showing on the screen. So right here, like you can do like anything with like this arrow right here. So Alex can show an example.
That's just, I mean, isn't that Scratch?
Yeah, it's like Scratch, but this is called Snap, and it's a little more it's a little bit more involved. Scratch is a little more simplified, but you have a lot more to play with Snap. There's lots and lots of little tabs for you to sort of go through.
Those all the same as Scratch.
I've only looked at Scratch a couple times. Does it look the same?
It's pretty much identical. But I
Really?
think Scratch is better because it's a little more developed.
Probably.
And the interface is easier than Scratch.
That's kind of true, yeah. But I think a lot of like Berkeley students made this Snap one, so like it's kind of like special to us because I think Scratch is made by like another university, so that's why we're using it. But you can use
Scratch is
Scratch too,
made by
though.
MIT.
Mm-hmm.
Yeah. Berkeley one's cooler. I like the look of this. It looks less Scratch is a little bit too bright for my liking. I like the dark mode. This is actually my first time looking at Snap. Yeah, blocks look better. Yeah. I think I can probably show you. This is what the code that I sometimes work with looks like. So this is a sample solution for a homework question that I have for one of my homeworks. And this is basically the sort of stuff that I would be writing. If you guys can see my screen, but there's an important thing that when you're coding, because when you're coding is basically an extension of your own personal like thinking, right? And so just like in other problems, there are many different ways to come to the same answer. Same thing with coding. Sometimes like, maybe there's just a few, but there might be a lot of different ways to arrive at the same problem. Like, oh, instead of doing a line, I'm gonna do a bunch of tiny little curves, right? Or you could just make a line, right? Two very different outcomes, but you'll get two very similar outcomes, but the methods you get are different, right? So this is the type of code that we'll be writing. And in order to, science is all about like being able to reproduce whatever experiment you've done. So you need to be able to explain your code. So that's what comments are for. And I don't think, I'm not sure because I haven't used Scratch or Snap very much, but I don't think they have a comment function, mainly because it's already very descriptive in the way that you're putting down your code. So different languages use different symbols, but in MATLAB we use the % symbol to put down comments to say, oh, I did this here because I want to have more data points. There's a lot of fancy technical terms in here. Interpolation for more granularity. That just means I want more numbers to make the line smoother. Right? So, there's a bunch of comments in here to explain why the coder is doing the things that they're doing. So that's another thing to keep in mind when you're coding, that since science is about being able to reproduce your findings, you have to be able to explain the methods that you took to arrive at your answer. So yeah, lots of complicated things that I personally don't quite enjoy, but very useful, very, very useful.
Are you guys interested in computer science and like doing it in college? I mean, what grade are you guys in? Daniel says he is. He's in 11th. Oh, awesome.
Nice.
What about you, Blake and Casper and Kim?
What grade am I in?
Mm-hmm.
I am in grade 8 now.
8th, middle school. Cool.
Yeah.
What about you, Blake?
Fourth.
Fourth grade.
That's
Wow,
awesome.
nice.
And you're doing this. That's pretty cool.
Yeah, I didn't get exposed to coding until high school. I had a little bit of exposure in elementary with the Lego Mindstorms, that thing that I was talking about before, but I didn't really get to do it. The other smarter kids were doing it, and I was like, okay, I'll just watch. So the real beginning of coding was in college, where I actually sat down and started typing stuff out. And it can be quite frustrating because sometimes you're like, it should work. Why doesn't it work? But persistence is key, right? People, all of this is written by a person, and you are also a person. So therefore, you can make this happen, right? It doesn't always have to be this complicated. A lot of this stuff you can do by hand, but sometimes just typing it out is better, since you can do it for a lot of different situations. Yeah. Let's see. It's very difficult to.
What's everyone doing right now? Are they still doing the Flappy Bird or the Minecraft code?
I'm not sure.
Hmm.
What's everyone up to? I think Daniel did say he was done a little bit earlier.
Mm-hmm.
How do I use the stretch function on the snap thingy? How do I make it stretch? Yeah. Where is it located? Because there's a stretch amount, but there isn't a stretch it. I don't.
This. I see what you're
Yeah,
saying.
but that's an input. That's not a command. How do I?
Oh, I see.
Commands turtles. Probably should have familiarized myself with the program.
I like if you put like control and then put that as an input.
Yeah.
So like when flag is or
what does warp do?
Warp, I think that takes you. So basically, okay. So warp is just like. Let's see if I can. All right. I'm pretty sure the warp function is when you have a condition is met. So like something has been set to be true, then you can warp past this, right? It's like saying, hey, skip this step. Or, hold on, maybe that's not it. Let's see. So what you can do is you can also press right click and then help. So if you see here on my screen, there's a help and you can read what it says.
So it's exactly what the run without screen refresh does in Scratch. So it just makes it so instead of going, it just goes.
Yeah.
Okay, that's really helpful.
Oh yeah, a big thing is there's this thing called infinite recursion, or we colloquially, so like slang, we say it goes infinite. In coding, what happens is that sometimes your computer will just take a long time, and if it takes too long, they'll just be like, hey, this thing goes to infinity. We can't help you because we've run out of memory to do this process. And so when that happens, it could come down to a number of factors. It could be that one, it actually does go to infinity and the code doesn't stop because the condition isn't met, like the initial condition. Like, hey, we can never meet the condition, so you're gonna have to fix the code.
Was that for me? So I figured out how to make it stretch. It's actually switch costume to whatever, and
Mhm.
because that's an input, and so is the stretch. So you take out the switch to costume,
I see. I
and then
see.
you take out the stretch, and I guess you just put it in.
See, that's the problem solver right there. My screen's getting so cluttered. I can't. Oh boy. Yeah.
It was in the help section.
I think overall I think I prefer this to Scratch. I think that's personal preference though.
I think that this one is good, but I'm still used to Scratch. Does
Yeah.
it have all the blocks in it? Like all the blocks as Scratch?
I don't think so.
Oh.
Yeah. Drag and drop. Yeah. Typing commands is like, you can prefer that. Yeah. Cam, I see what you're saying. Yeah. Snap has probably more commands. Yeah, it's more developed than. Hold on.
Yes, and
Yeah. So if you guys have any more questions, yeah, Scratch is more polished. Yeah, Snap is, I think, a little bit more comprehensive. Scratch is more like very introductory. If you guys have any like burning questions that can be answered in like 40 seconds, Summer and I are still here for some rapid fire answers. If not, I'll just stay here until the breakout room closes.
So if everyone is back, I think we can go ahead and kind of conclude just this activity. So does anyone want to share anything they learned or anything they were really proud of building? Or kind of just anything you thought was really fun that's not on the slide, but yeah, if you want to share anything you learned, either in the chat or by unmuting yourself, anything that you was really cool that you built, or just anything you had fun doing. It was fun coding. The Flappy Bird game was fun. That's really great to hear. Yeah.
Yeah, all right. So the takeaways from our lesson today is that you can do anything with the right resources. We're glad that we had the chance to like show you guys Scratch, Snap, and like Flappy Bird and Minecraft like coding games, because those can be super fun. It's a great way to introduce like what code is, especially if you're learning it for the first time. So yeah, so you have all the resources there. Like look for Snap and Scratch tutorials like on YouTube, or continue doing it at home. But yeah, thank you for coming out today. I know it's super early in the morning, but really appreciate each and every one of you for coming and hanging out with us. So yeah, so as I mentioned earlier, Beam is like a UC Berkeley org on campus, and like we actually have a website and an Instagram and a Facebook. So like if you ever like want to learn more about Beam or interested in UC Berkeley, like just like check out like our Instagram and see what we do, or go on our website to see like all the other lessons that we've written taught to and everything. But yeah, that's about it. But thank you everyone.
Bye.
Thanks everyone for coming. We hope you guys learned a lot and learned something new.
Thank you. Thank you.